M1, May 2012, question 3. This is a momentum question, so I'm going to start with a quick sketch to show the gun of mass 6 kilograms and the bullet of mass 0.2 kilograms. Before the shot is fired, both the gun and the bullet are stationary. After the bullet has left the gun at a speed of 330 meters per second, and the rifle will move into the marksman's shoulder. Using conservation of momentum, which says that the total momentum before equals the total momentum after, with 0 before has to equal 6 times, and be careful here, minus v, it is a vector for velocity, plus 0.2 times 330. Rearranging that equation, we get that v is 11 meters per second. Part 2, there are two methods for solving this. The first one I'm going to look at is where we use impulse. So if we just consider the gun, it starts at 11 meters per second moving into the shoulder, and its final velocity is 0. Impulse equals mv minus mu, so that will be 6 times 0 minus 6 times minus 11. So the impulse is 66. Impulse is also equal to ft, f being force times time, so 66 has to equal force times the time, which is 0.1, so the force is 660 newtons into the shoulder. Alternatively, you can answer this question in part 2 using the equations of motion. The rifle started at 11, its final velocity is at 0, its acceleration we're trying to find out, and it took 0.1 seconds. Using v equals u plus at, 0 equals 11 plus 0.1a, giving an acceleration of minus 110 meters per second squared. We then use Newton's second law. Resultant force in the direction of motion equals mass times acceleration. The force will be 6 times minus 110, so negative 660 newtons. Same answer, the negative, just showing that it's going into the shoulder.